Okay, we're recording, guys. All right. Guys, quiet, please. Thank you. Awesome. All right. Yeah. All right, you tell them. So 6, 7. It's right here. That's O. 11, 7 is right here. That's P. And you want the distance between those 2 points? Well, that's easy. How far is that distance? 5. Yeah, duh. Right. So that's not hard. That's easy, right? Okay, good. Easy unit, right? No. Now, next up, plot the point 9, 11, which is going to be right above it. So let me erase this part just because it's a little bit in the way. So 9, 11 is going to be not exactly halfway between. Going to call it point B. So what's the distance between O and B? So you could use distance formula. There's a formula called distance formula, and it looks like this, by the way. In case you're curious, that's the distance formula. But what do you think that looks like? Like, what do you think? How do you think that's derived from what main concept right triangles? You've got totally right? So you don't really have to use that formula if you don't want to, because it does look a little messy with all the subscripts and whatnot. Personally, I would just draw right triangle, draw the legs. What are the lengths of the legs here? So clearly that's gonna be 5. Okay, so not too bad, pretty easy, right? Okay, now let's see where we're going with this. Oh yeah, good job. Yeah, you totally got it. Yeah, so now let's plot 10, 4. 10, 4. I'm not gonna move my screen just because I want to keep the graph here. 10, 4 is right here. We'll call this point C. And what's that distance? Same thing, right? Same. Right? Okay. So what are we noticing here? OP is 5. OB is 5. OC is 5. Those 3 points, both B, P, and C, are they of equal distance to point O? If I keep doing a bunch of points that are 5 away from O, what shape do I form? Oh. Yeah, and kudos to Ms. Wong. These are actually much better than how I create these notes. I like this. Okay, so yeah, so we know part C. I'll just do part C right here. That's also 5, right? So part D is asking if you formed A and C correctly, you should have gone the same length. Suppose I want to find an equation that could discover any point of equal distance around 6, 7, which is a center. O is a center, right? Write an equation that relates X and Y. Okay, well, if you think about it, that right there is the equation I'm using, right? That's a relationship between these X coordinates and this Y coordinate. What you could do is this. And actually, let me clear the screen for now, because I think you guys get A and C. No question about A, B, and C. You guys are good? Yeah, okay. So let me mosey on down to D. And let's do this. So write an equation relates X to Y. Here's what's going to happen. Generally speaking, let's say I have a circle that looks, let's say I have something like this here. Okay, not the best looking circle, my apologies. Let's say it calls X, Y. Let's say it calls H, K. You guys are already familiar with H and K, right? Okay, so. And then what's that segment called from the center to any point in the circle? What do we call that? Good, radius. Yeah, see? Good. GeoGeometry treated you guys well. Good. All right. So here's the deal. If I draw a right triangle, right? I'll just superimpose this right triangle over here. That's R. The horizontal leg. How would I use the coordinates to get an algebraic expression for the horizontal leg? Like you have, so what's the X coordinate at that corner right there? Over the right.
X minus H.
And in general, the center, the X coordinate is H, right? How do I get an algebraic expression for the vertical leg? Using the coordinates here.
Y minus K.
Y minus K. Totally. And if I Pythag it, you get X minus H squared plus Y minus K squared equals R squared. And that's the equation of a circle. Really simple. If you see it that way, you'll never forget it. Just, hey, I got a center, I got a point in the circle, I want a relationship, right? For every x and y value in the circle, I want a relationship. How does they relate? Well, guess what? What is the definition of circle in the first one, Arya? What's the definition of circle in the first place? Oh, okay, no worries. A set of points equidistant from a fixed point. Okay. And what do we call that fixed point? We call it the center. H and K is your center. And equidistant, that's going to be the radius, right? The radius represents that equidistant part. So for this particular example that we just did, guess what? For this particular example, what's the equation of my circle? X minus 6 squared plus y minus 7 squared equals 25. So any point on that circle will satisfy that peak equation. Because now I have a general equation for it. Yeah. Circles are probably the easiest conic section to deal with. So that's what's happening there. Questions at all? We're cool? Okay. So let's move on to the next page. And let me actually, before I hit up these problems here, let me actually go to a whiteboard and kind of just show, and actually let me do this first. Double snapped cone images. Okay. This is good. I like this. All right. Here we go. Okay. So double nap cone. The double nap cone is two cones that where the vertices are going toward each other. What I used to do, and actually I didn't have a chance to do this, but maybe next week I get a chance. I would go like Michael's Arts and Crafts, and I would get like styrofoam cone, get toothpicks and connect them. And then I actually bring my cutting board and a really sharp knife, like this, except it dulls the knife and a knife is very nice. But I take the sharp knife and I cut the cone. And you cut the cone in various ways. Like let's say I take the blade of the knife, right? Knife, cut it parallel to the bases, right? What cross section are you gonna make? Circle. What if I slice at the corner here, right? And slice at the corner. That cross section would be a problem. What if I cut at an angle to the body of the cone, not parallel to the base, but at an angle? You look at a cross section, it's an oval, which we call ellipse. What if I take, this is a question where I want to come figure it off. But if I cut it, try to do a perfect cut, where I want to cut an equal kind of cross section here and here. So I do it down both here and here. That cross section forms what we call hyperbola. It's like two parabolas going against each other, or sorry, going away from each other. So that's what's meant by conic sections. These are cones where we slice them in various ways and get you these shapes. The circle is the most basic, which we're going to talk about today. And maybe we can handle the parabola today too. I'll save ellipses for Friday and hyperbolas for next week. And then we'll kind of put it all together and then see how you guys are feeling about this. All right, anyway, let's move on to the next page. So let me get started with maybe parts. Yeah, I'll just do part A and you guys can do parts B, C, D in your table groups. And then once we should be able to finish circles pretty quickly. It's a pretty easy topic. So anyway, let's take a look at part A, right? So for part A, let me share again. Here we go. Okay. So for part A, the graph for each equation below is a circle. Identify the radius in the center of the circle, then graph the circle, blah, blah. Okay, well, that's easy. What's the center? Center's, what, guys? Yeah, just like shifting, right? Just like transformations, right? Not that hard. You guys know this. And what's the radius going to be? 7, totally. The square of 49, right? So guess what? -3, 4. Right here. Okay. You want to go 7 away. And by the way, when you graph it, just to be safe, go 7 left, 7 right, 7 up, 7 down from the center. That's good enough. You don't have to do more than 4 extra points. It's not necessary. Unless you're a total perfectionist at this, I guess. I don't know. And then I'm going to cheat because I have a little thingamajig. Hold on. Yeah, I'm gonna cheat a little. Let's see if I could.
Oh.
Okay. Yeah, there you go. There's a circle, right? So not hard. Okay, once you guys try B, C, and D, for D, you have to divide both sides by 15, right? To get the right form. Do you guys remember doing completing the square? We're gonna have to get to that eventually. Actually, we'll do that as the last example for circles today before we do parabolas. Okay. So I'll give you guys maybe a minute or two. Shouldn't take too long.
Over 2.
You guys' hair looks the same, by the way. Yeah, a little bit. Huh? Yeah, yours is a little more curly. His is more wavy. Okay, so let me do this quickly here. 0. 0, -3.
I like to take this myself.
Okay, guys, so B should look like this. Here's 5. It's hard to estimate. I don't expect you guys to be perfect, but it's like 2 point something, right? So go a little bit more than 2 away from up, down, left, right. So not too bad. Center 0, -3. So we're cool, B. Okay. And then for C and D, C and D, what do we got here? The center 0, 0, 10, 10, 10, 10. Getting a little lazy there. Divide everything by 15. X plus 1 squared plus y minus 2 squared equals 4. So -1, 2. Go 2 away. There you go. So we're good? Awesome. Great. Let's look at the next example. Write the equation of circle, blah, blah, blah. The pass by point center. Not hard at all. Right off the bat, let's get the radius. What do you guys get for your radius? Root 61? Yes, 5 and 6, or call R. So 5 squared plus 6 squared equals R squared. R squared is 61. You don't have to say root 61 because we're just going to put 61 in the equation. X plus 2 squared plus y minus 5 squared equals 61. Cool? Good. Okay, let's keep moving. All right. So 3, 2, -5, -4. Oh yeah, what's up?
So for the sum, can't you just equate these two equations so I see 6?
Right. Oh, I'm gonna go over that though.
I'm getting like.
Let me go over that first. Yeah. Well, I'll get there. Okay, yeah. Okay. So looks like you guys kind of got ahead, which is good. But let's just do this really quickly. The center how do you find the center between 2 points? What do you guys do? Yeah, how do you find midpoint? What do you do to the coordinates? Average, yes. Average the coordinates, which should be -1, comma -1, I think. Yep. And visually that makes sense. The radius should be 5, I think. Yep. The equation should be x plus 1 squared plus y plus 1 squared equals 25. Okay, not the best looking circle, but we'll go with it. Then next up is questions so far. How I got that? We're good. Yeah, good. When you find the diameter. Oh no, we know our diameters. We know the 7 connected points will be the diameter. We're told that. Yeah, we're told that. But thank you, Troy, for bringing that up. And then 3, 2. 3, 2 is right here. Now, when you're tangent, what's true between the radius and the tangent line? This is good review of geo. What's true between the radius and the tangent line? Oh, it's true. See, that's not your challenge. You're good. All right, you're good. So perpendicular, right? So find the equation. Now, the board geometry. Plus is more element too. What's true about the slopes between perpendicular lines? Now you're circles. If I know the slope of this guy, then I know the slope of this guy, right? So what's the slope of my diameter? Slope of the diameter is going to be 6 over -8 or -3/4. So slope of the tangent line is what? Did I make a mistake? You are correct. Is -6 over or actually, you know what? It's just 6 over 8. Yeah, because I went from left to right. You're right. You guys are right. Duh. Yes. So slope of tangent line.
Yeah.
Is going to be -4/3. When you write the equation, I don't care if you put it in slope to intercept form. In fact, I actually prefer you don't. You should get a habit of just doing point slope form and being happy with that. Because in calculus, that's what they care about in AP calculus. They just put point slope form and move on. So I'm just going to say y minus 2 equals -4/3 x minus 3 and call it a day. No need to rearrange that into slope intercept form. I don't care. Or in a standard form like ax plus by equals c. Point slope's totally cool. In fact, College Board, I'm doing AP Calculus next year, they prefer that because it makes their job much easier for grading. And plus, you're less likely to make an error if you don't move things around, right? So leave it like that. Totally cool. So that's number 4. So questions so far? Okay. Now let's move on to 5. And Audie, I'll get you a question about 5, but I haven't read it yet. Okay. So what's happening here? You got a circle. You have a line. Find the points where the circle and the line intersect. Okay. Well, let's just graph it really quickly. That shouldn't be hard at all. Okay. Three comma -4. And the radius is 5. So clearly they intersect twice, right? If I were to guess, maybe it's 6 comma 0. I don't know. Like let's work it out. I don't know. Maybe it's kind of weird. So if I plug in 6 straight up for x and solve for y, I get 9 y plus 4 equals plus or minus, guys, plus or minus So y equals -4 plus or minus 4. Yeah, does make sense. Y equals 0 or -8. So points where that happens would be 6, 0 and 6, -8. Okay, questions? And Audie, what was your question you had about that, or do you have a question? You good? Okay, cool. Got it. Yeah, it happens. But the graph confirms the algebraic solution, right? This is a lovely example of implementing algebraic geometry, or sorry, coordinate geometry in algebra, right? Because from the coordinate perspective, we see what's happening, right? From the algebraic perspective, we see what's happening, right? So it makes sense. They confirm each other. So it makes it, our understanding more rich, right? Okay, last one for circles, and I'm gonna definitely venture into parabola because I think we can. And we'll see how far we go with parabolas. Okay, so this part is a part you maybe are a little rusty. I haven't done it with you guys yet, but I'm sure you guys have done this in the past. You want to get this in standard form, meaning you need to make this equation look like this. Standard form. X minus h squared plus y minus k squared equals r squared. So what you're going to have to do is use a process called completing the square, which we're going to do a lot over the next few days, like a dozen times a day, probably. I don't know. On the homework, I don't know. We'll see. So completing the square. So I'm going to move. Let's go to red. I'm going to kind of somewhat lump the x's and somewhat lump the y's, Okay, now. How do you do it? Good. Yeah, because your goal is to make it look like a perfect square trinomial. You want a perfect square trinomial for both x and y, so you can make it nice and tidy as x plus something squared or y plus something squared in parentheses. So you need to do the process of completing the square, which means half of 2. Hold on. Half of 2 then squared, which is 1. And also half of -4 then squared, which is 4. But you must add it to the other side as well to keep it balanced, right? So final answer looks like this. It does get a little more wicked when the leading term is not 1 or leading coefficient, but we'll cross that bridge tomorrow and next week. Not tomorrow, sorry, Friday next week. Yeah, go Ryan.
I think I missed this. Why do we multiply like the 2 and the -4 that one?
Oh yeah. So when you complete the square, the process. No, and also. 1 minus 2.
Okay.
Yeah, sorry. You take half of this coefficient and square.
Okay.
By doing that, this turns into a perfect square trinomial, meaning factors like this. You want this to factor like this, so you can identify the center and get it to standard form.
Okay.
Likewise here, take half this is squared, because a perfect square trinomial looks like this. A plus b squared equals a squared. And guys, Ryan asked some really excellent questions. So let's focus here, because sometimes we memorize this. Why do I take half of the little coefficient? So by taking half of this, guess what? That's 2 is gone, right? And then when you square, guess what? You get a squared, b squared. So it works itself out. Okay. When you do so, it kind of forces the issue to make it look like this. When this is expanded, it falls. That's why we go that far. Yeah, now you know the one, right? Let's keep moving. Okay, circles is done. Let's see how far we go with parabolas. Might not get terribly far because we get at 35 and you guys still have another class. Okay, so parabolas. What is a parabola? A parabola is simply a quadratic function, right? It's a graph of quadratic function. Before I get too carried away with this example, let me show this to you guys. And this is gonna be fun. Because I'm gonna actually ask you guys to do derivations down the road. Hold on a sec here. So when I taught this in, oh, come on, here we go. When I taught this in Algebra 2 Trig Honors several years ago, I'd actually do these derivations for my students. Okay, here we go. So the derivation of a parabola. I'll put this in school because I want to get a chance. Let's assume your vertex is 0, 0, and the parabola's open to let's assume that. Now, what is the definition of a parabola? The true definition of a parabola, which you guys probably haven't learned, but now people know, is that all points of equal distance from a fixed point, which I call focus, and a fixed line, which I call the directrix. So let me just draw this diagram over here. So if I have like a fixed point, and let's say I have like a fixed line, let's do this, let's do a dash line here. So I'll call this my focus. I'll call this, it's a weird name, I don't know what to call this, the directrix. What are all points of equal distance between these two? Definitely this dot right here, right? Whatever the distance is matters, they would be the same. Probably another dot over here somewhere. If I were to draw that and that, those are probably the same. And the distance between a point and a line is always the shortest possible distance. But if I were to just keep figuring out all these points where it happens, right? Not quite a circle, but it forms something like this. A parabola. Like if I were to take this point, right? Those should also be the same. Whatever this is from here to here and there should also be the same. That's the definition of a parabola. It's actually the proper way of defining it. Now, why does it become x squared? It's not just something magical. There's actually a reason for it. Here's the reason why. And I think you guys could handle this derivation. It's not too bad. I'm not going to do it from scratch, but I'll kind of explain the diagram here. Okay, so after the focus, D is the directrix, x, is a point of the project. So this distance from x, y to f, I'll call it D1. Distance from x, y to this line, the directrix, I'll call it D2. D1 must equal D2 for this to work, right? Well, D1 is simple. That's just doing some distance formula, right? Not that hard. So that's what I did for distance formula. I took what I do. Oh yeah, another thing too I forgot to mention. Another thing that's cool. The distance from the vertex to the focus we call P. Or from the vertex to the directrix I also call P. So P is this distance from 0 to, or from the vertex to the focus, or from the vertex to the directrix. That's called P. So I'm going to call it 0, P because the vertex 0, 0. I'll call this line y equals negative P because P below the vertex. So the point here would be, of course, 0, negative P or x, negative P for that point there. So if I find D1, this with this, you get that. If I find D2, xy with x, negative P, these show the same x coordinate, this straight shot down. Y minus P, x minus x, you get that. Does that make sense? I got D1, D2 with these, all these, and I'll share this with you guys, don't worry. Does that make sense? I got those distance formula. Yeah. Yeah, I know it's a lot going on here. Well, if I set these equal to each other and square both sides and go to some algebra, magically you get an equation with y equals x squared. So that's why quadratic functions that have like x squared in them are parabolas, because the definition of parabola is a set of all points of equal distance from a fixed point and a fixed line, which forms this kind of U-shaped thing. And when you do it algebraically and go through the derivation, you want being y equaling something in terms of x squared. And P happens to be the distance from the vertex of the focus or vertex of the directrix. So that's where the equation of parabola comes from. I also have a video on this too, like a more detailed video, which I can share with you guys. But let's now go back to the notes and do some of the problems. So again, it's another cross section of the crown, but you slice out a corner instead. Every point is of equal distance to a focus and a line called the directrix. So the focus is at 0, 2. Directrix at y equals negative 2. And the parabola, I'm just going to kind of do a rough kind of sketch. Will probably look like that, kind of rough sketch, right? So you're asked to graph it, identify the vertex and axis symmetry. The vertex is at 0, 0. Axis symmetry is x equals 0, because it goes right through the middle. The graph I already took care of. That's easy. But part B is asking to write the equation. Okay, let me give you the general formula for the equation. The general formula is going to be this. If it's a I'm going to call it a vertical parabola. If it's a vertical parabola, it's going to be this. Y minus K I know it looks weird, but just go with it. It's a little strange, but I did do derivation with you guys. The derivation said it was x squared equals 4py, right? But now we have a vertex I have to worry about, h and k, so we just incorporate h and k in the transformation. It's weird, because usually you want to isolate y. I know that's what you want to do, but I rewrite this way because it's going to be easier for you to work with down the road, right? So h is the x coordinate vertex, k is y coordinate vertex, p is the distance from the vertex to the focus or from the vertex to the ground. And it's opening up. P is positive when it opens up. And P is negative when it opens down. That's for a vertical parabola. There are going to be sideways parabolas. We'll get there. We'll get there in the next example. There are sideways parabolas too. So what's P here then? Positive 2. So for part B, I'm going to write this. 8 y minus 0 x minus 0 squared. Or 8y equals x squared. If you want to write y equals 1/8 squared, 1/8 x squared, go ahead. I don't care. But that's what we usually do. And you can leave it like this. So this is a vertical parabola form. Yeah. And by the way, I'll give you guys a very detailed formula sheet that I'll find on the test. But just as a reference, I'll give you guys a very detailed formula sheet that has all the formulas for all the conics. By the time next week, we'll have covered everything, and then we'll start doing some crazy stuff with them. So that's where we really have a lot of fun. Okay. Okay, example 2. Okay. So for example 2, let me clear the screen. All right, let's plot the points. -2, 0 is your focus. Come on. Director is x equals 2. Now, the director, just so you know, the focus has to be inside the parabola. The director is behind it. See, always. So I expect my parabola to kind of look like this. This is kind of a rough sketch. I don't know if it's accurate, but it's not totally accurate, but it's fine. The vertex is 0, 0. Axis symmetry is now the x-axis, or y equals 0. And now for a horizontal parabola, the general formula looks like this. 4p x minus h equals y minus k squared. So it's just reversed. You guys remember doing inverse functions last year? Yeah. That's exactly what we did. This is an inverse of sideways parabolas and inverse of the vertical parabolas. Or horizontal is inverse of vertical. So yeah, what's my p-value here? Yeah, if p is greater than 0, you're going right. P is less than 0, you're going left. Okay. So yeah, p actually be -2. Bob, you have a question?
Yeah, so
Yeah, go ahead.
P can be greater than 0 if the parabola is pointing right or vertically. It's only less than 0 if it's pointing left.
Or down. Or down, right. So that's the equation for that one. Or you could say x equals -1/8 y squared. That's fine too. Okay. Actually, we're doing pretty well here. Questions so far? No? So let me summarize on the next page and have you guys try examples 3 and 4. So let me summarize on the next page here. Orientation. So this is all just things I've already said, but I'm going to say it again. vertical, horizontal. I didn't do myself enough space, did I? 4p x minus h squared equals y minus k, or 4p y minus k squared.
Shouldn't the square be on the other side?
Wait, did I make a mistake? No, if it's vertical, no. Oh, you guys are right. You guys are right. You guys are right. Thank you. Yes. My apologies. Yes, thanks. My bad. Yeah, my apologies. Axis symmetry will be, because going up or down will be x equals h. We're here to be y equals k. The directrix would be y equals, it's going to be p away from, just give me a sec here. So if it's hk, so it'd be k minus p. Here would be x equals h minus p. And then the focus, which I didn't give myself enough space here. Because it's going vertical, it's going to be h comma k plus p. But this will be h plus p comma k. Yeah, I got that. Okay. I think I got it. Yeah. So p is a distance from the vertex to the focus, also from the vertex to the directrix. Now, I think everything here so far has a vertex at 0, 0, except on the next page. So why don't you guys try examples 3 and 4? You're given these things. You're asked to graph and write the equations. Go ahead and do it. So examples 3 and 4, see how it goes. Give you guys about 3 or 4 minutes. And I'll try to sneak in one of the examples on the next page.
This is 3 over 4.
Okay. Hold on a second. I gotta take attendance. Forgot to do that. Okay.
Wait, it literally says that's the directrix.
Yeah.
The P.
Oh, it's 3 over 4. Yeah, you did right.
That would be directrix.
You did right.
Focus.
You did right.
Directrix of focus would be
You
one.
did right.
Yeah, you stop saying UV's right.
You did right.
You're saying
It's the point in the middle. It's from the directrix to the focus.
Okay.
This says vertex. Focus is the one that got divided by 2. Vertex is the matrix of the
Oh,
if it was directrix of focus, you have to divide by but it's not. But it's not. The vertex.
Oh, it's the vertex. Not even matter.
UV's got to focus, right? You like that? Okay. I think I've.
Still thinking about it.
Okay.
Okay. So why? If he's roughing the case, this is the vertex. That's that.
Vertex to directrix is P. Vertex to focus is P.
What do you guys get for P for this example? -3/4?
Yes.
Yeah.
Definition.
No?
Whoa, wait, what? He got 3. I thought it was 3.
Yes.
Oh, sorry. I thought I was doing focus of directrix. My bad. -3/2. Because going down, right. It's going down.
Okay, yeah, but like the point is that we have
No.
Matthew, go ahead. Yeah, go. Yeah.
I think so. I still think they are not wrong. Because the vertex is here.
Vertex is 0.
Vertex is here. That means that no. Focus is here. Oh, yes.
Okay, we're cool? You good? Yeah? All right, let's look at example 4. All right, vertex. Oh, come on.
No, P is on the next.
0, 0. Right here.
P is on the X.
Focus is going to be now. One thing I would do, guys, is I'd say, give me a sec here. So remember our general formula is this: 4P. Actually, let me take it back.
It's wise.
Right? That's our general formula, right?
I am sir.
So what's your H and K here? 0, 0. So right, I should move that 3 over to the other side. So 4P equals 3. So P is 3/4. And it's going to the right.
We already got that.
Okay, so
It's 3/4 comma 0. And the directrix would be x equals -3/4. Yeah. I should have done them a little more accurately, just so you know. I didn't quite. Actually, I didn't do too bad, because if I make a little table here, if I plug in 3 for x, y would be 3 or -3. So I didn't do too bad, because you have 3, 3, and it kind of missed with 3, -3. But you do want to be a little more accurate, not just as haphazard as I was. So that's example 4. How do I get where? Okay. All right. In the interest of time, let's stop now. I figured this last page I could do with you guys on Friday just to wrap it up. But you have enough to do the homework. The homework files are here. They're just from the textbook, the photocopies. I'll have it select long set. Yes. I'll find it actually in the next few minutes. I'll put it in school sheet. But this is a copy of the textbook. So maybe the first half this unit. I'm gonna put it in school sheet.
little bro.
Yeah, that's real. I got to know you about that. What you thought about it.
Don't worry.
No, you're right. No, I was.
We're getting into 555. No, I did the squat set too, but someone was like, "No, I'm going to the shower. I'm going to study." Like, what? Yeah.
You know, you're right.
Let's see.
is, you know, your clothes also. They should just go shower.
Let's get 5 by 5.
Yes, oh, I thought. No,
Yeah, exactly. You're like, why would I mean, it kind of, but like, but like, 5 by 5.
If you're not, if you're doing it right, you just maybe you can else. You ever think else to do a 5 by 5? Funniest thing. When he leans over like a bird when he's doing splits. Like I don't know what he's doing, and then he's like, "All right, what do we got?" I'm like, "No, what the hell? It's the worst. It's the worst." What are you gonna
She was more wet. I guess. I usually look at that.
5 by 5, like 45 pounds.
David was honestly.
Apparently David was like, we were like, David,